So at this time, we are talking about select clause and the functions. So far, we have covered several details with respect to how to project data from data frames using select with column and also expression. And then we have gone through predefined functions such as string manipulation functions, date manipulation functions, how to drop the columns, etc. Now let us see how we can actually develop a function and use it on top of data frames. So when it comes to creating our own functions, it is called as user-defined functions. When it comes to these user-defined functions, there are simple UDFs as well as aggregated UDFs. So for example, if you want to develop a function like sum or average or min or max, they are considered as aggregated UDFs. Simple row-level transformations can be performed using simple UDFs. So developing a simple UDF is pretty straightforward. You just have to develop a standard Scala function which take one record as input and return another transformed record as output. As long as you satisfy that, you can have whatever logic you want. But when it comes to aggregated UDFs, it is a bit more complicated. You need to understand the life cycle and you have to implement certain interface or extend a class and override several functions to achieve the aggregated UDFs by yourself. And we will talk about how to develop aggregated UDFs at a later point in time. For now, we will focus on how to create simple UDFs and how to use it. So as part of it, we will understand integrating a simple UDF with Spark SQL or data frame operations. And then we will be using that knowledge even when we talk about aggregated functions. Only the development process of aggregated UDF will change. But using as part of our data frame operations or Spark SQL, steps are same, whether you use simple UDF or aggregated UDFs. So the steps include that we need to create a variable for function, or we can actually define any standard function. And then we have to use this and we have to pass that function to it. And it can be used as UDF going forward. When we actually invoke this and pass a function to it, it will return an object of type org.apache.spark.sql.functions.udf defined function. Once it is created, we can use it as part of any transformation function such as select, where, filter, groupBy, etc. by using data frame native approach. However, if you want to use it as part of SQL style syntax, we need to register UDF as SQL function. We can do so by using spark.register.udf. It actually create a temporary function within the Spark session that can be used as part of Spark SQL. Now let us actually go ahead and see a demo. We'll be creating UDF to extract year from date, which is string, and we will convert it into integer. So I'm launching Spark Shell here. Let's start with JSON data. So I'm trying to read orders data, and the path I have given is of my orders, which is in JSON format. So this is my location in the current environment where I'm running this. Earlier I used to use /mnt/c blah 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 because I was running in Ubuntu session as part of Windows, but now I am directly using my Mac. That being said, we can preview the data by saying orders.show. There are 4 fields: order ID, order customer ID, order date, and order status. So in this case, I want to extract this piece from order date and convert into integer. And further, I want to create a user-defined function because I want to use several times as part of my applications, as part of our project or as part of our enterprise. That being said, either we can have a named function or we can have anonymous function, whatever it is, and you can actually register as UDF. In this case, I am creating a variable, and variable name is get year as int. It will take a string, so we'll be passing date in the string format, and it will return integer. Okay, so this is how you can actually define variables of type function when it comes to Scala. So you need to be familiar with this syntax. We can also have named function. This one is anonymous function, and we are assigning an anonymous function to a variable called get year as int. And once this is done, get year as int will be of type anonymous function. We will see those details in a moment. Once you have the function specification as part of function definition, you can write as many lines of code as you want. If it is single line, you can actually write here. If you want to write it in multiple lines, you can write it like this. And now we can actually take the argument like this, underscore dot, and then split, and then hyphen. So in this case, we are using this hyphen as delimiter, and we are trying to split the data. Once it is split, it will return an array. The first element of array will contain 2013. The second element of array will contain 07. The third element will contain this entire stuff. Okay, so in this case, we are interested in only the first element. So I can actually say of 0, and then I can say to int because I want to typecast it into integer as well. And we can see that the return type of this function is of type integer, and then hit enter. Now get here as int is of type function, which takes one argument of type string, and it will return an integer. Okay, we can also have a named function instead of anonymous function like this. So we can also say def get year as int, and it takes one argument, let's say a, and the data type is of type string. Return type is optional, we don't need to specify the return type. If you want to specify the return type explicitly, you can actually say like this is standard Scala function, or you can ignore it also. Based upon what you are writing as last line, it will be returned automatically when it comes to Scala. Now I can say a dot split hyphen and then 0 dot to int. That is what will be returned, and we can close the bracket, and you can see that get year as int is a function, and it takes an argument a of type string and return integer. So either we can pass it as a variable or function directly like this. Now we need to import org.apache.spark.sql.functions. It has a function called UDF, and then you can actually create a variable. You can use whatever name you want. So in this case, I'll be using get year as int UDF equal to UDF, and then you can actually see the syntax of several overloaded functions with respect to UDF. So in this case, we are using one of these overloaded functions which take a function as argument. So in this case, I'm actually passing get here as int, which is nothing but of type function. Okay, I think we need to pass it as variable only. We cannot give the named function like this. Let me see. Let us stick to this. There should be a way to actually pass the named function also, but in this case, we are passing unnamed function by assigning it to a variable. Now I can actually use UDF and it works fine. So the UDF take in this case a function which actually returns an integer type, and you can see the details of it here. Now we can use this as part of our data frame native operations by using this name called get here as int UDF. Already we have the data frame, which is nothing but orders, and you can say order.show to preview the data, and you can see the date here. Now I can say orders.select, and our function name is get here as int, and then we can actually pass the order date like this, and if you want, you can actually give alias like this, and then you can close the bracket for select clause, and then you can say show. Okay, the problem is here it should be UDF. So when we convert it to UDF, it actually changed the data type from integer to integer type, string to string type, etc. And also when it comes to name of the columns, it actually converted to column type. That's the functionality which we get by using UDF and by passing the function and then returning into a variable, which is nothing but get here as int UDF, which is of type UDF. Let me show you once again. So first we have created this simple function where we have used the argument type as string and return type as int. But when we run this val get here as int UDF equal to UDF of get here as int, it actually converted that simple function which take a string as argument and return a integer as value into a function which take list of string type of sum of list of string type. So these are the arguments which are considered to be passed to this function. The reason why it is saying list is in some cases we might have to pass multiple arguments also. So all those multiple arguments will be treated as a list when it comes to arguments here. And when it comes to return type, we are returning integer as part of our Scala function. However, this UDF have converted that to integer type because Spark data frame only understand these things, and the type conversions will happen implicitly when this user defined function is created. Okay, that's why when we actually use this function as part of our select clause with the UDF name, and when we pass the column name like this, it is taking, otherwise it will not take. Otherwise our original function is only taking integer type, not the column type. However, when we actually invoke UDF and convert regular Scala function into UDF, it changes the argument types as well as the return types. Okay. Now you can not only use as part of the select clause, you can use it as part of where clause, you can use it wherever you want. So in case if you want to use it as part of where clause or filter clause or filter function, you can actually say like this orders.filter get here as int UDF and then order date and then 2014 and then show. It will only return the data belonging to 2014 January 1st. However, if you want to use SQL style syntax like this, you can pass the functions using SQL syntax like this by saying get here as int UDF and then order date column can be passed like this, and we should be able to compare like this. If you use this SQL style syntax, it failed. And let us see what is the error. It is saying this function is neither a registered temporary function or a permanent function registered in the database default. So to use this function in SQL style syntax or even as part of spark.sql, we have to register this as a temporary function within whatever default database the session will be associated to. And the way you can do it is by using spark.udf.register. So you can say spark.udf.register. Here we don't need to assign it to any variable. You can see here I am not assigning this to any variable. I'm just registering the function so that the function can be used as part of SQL. So in this case, we have to take the UDF type object. It's not regular Scala function which we should take. We should take UDF type object. You can actually see the syntax by saying spark.udf.register, and there are several overloaded functions for this, and we are trying to use the one which take the first argument of type string. So we will be just passing the string name. So and then second one should be regular Scala function, not UDF. I'm sorry, I was bad. So here the first argument should be the name you want to use as part of running queries. So in this case, I want to use the name get year as int UDF, and the second argument is, okay, there should be some other overloaded function here which take regular Scala function as argument. Let me see. Yeah, you can see here name string and then func. So in this case, I'm passing the regular Scala function as second argument. Okay, so here we can say get year as int. Get year as int is of type function, and now that get year as int is registered as user defined function as part of the default database. Unfortunately, when we actually use show functions, which is a Hive query, will not return these temporary functions the way it actually returns with respect to show tables. So there is a command called show functions. It will list all the functions that are available for us as part of Hive. However, if you actually say filter function, and if you say function equal to or double equal to, because it is listing too many functions here, I'm trying to filter. You see, it did not return the list of functions which have that name. So let me do this. Yeah, it is not returning. So unfortunately, show functions is not showing up these temporary functions the way it actually shows the temporary tables. However, the function is registered here. Okay, so once again, I'm showing the steps here. The way you can register is by using spark.udf.register. We are giving the function name which should be used as part of our queries, and the actual function itself, which is nothing but a typical Scala function here. Now, the same code which we have ran earlier, which did not work with SQL style syntax as part of filter or where, will work without any issues. We can also say orders dot create temp view orders. So in this case, I'm registering data frame as a temporary view, and then we can actually say spark.sql select star from orders where get year as int UDF of order date equal to 2014, and then show, and you should be able to see the results here. Okay, so this is how you can actually define a typical Scala function and register as UDF. It's very straightforward as long as you are familiar with how to create the anonymous functions in Scala and assign it to a variable, and that variable can be registered as a UDF, and we can use it as part of data frame operations, or that can be registered as a Spark SQL function as part of to use it as part of Spark SQL queries, and you should be able to use it as we have seen here. So if you want to use the function as part of SQL style syntax or even as part of spark.sql, you have to register using register.udf or spark.udf.register. That is the function name. Okay, so even if you define aggregated function at a later point in time, the steps to use it is the same whatever we have seen here with respect to simple UDF. We have to register by either using UDAF, I think, user defined aggregated function, and also we have to register by saying spark.register.spark. Let me hit tab here, and then yeah, you have to use just UDF, then register, and you should be able to register the user defined aggregated functions also.